Hey everyone, Mr. Newman here, and today we're just going to do a quick review on 4.0, 4.1, and 4.2. So let's get started. First of all, just as a reminder, when you multiply powers, you must add the exponents. An example of this is if you have 3 squared times 3 to the 5th, you get 3 to the 7th because 2 plus 5 is 7. Notice we do not do anything to the bases. The 3 stays the same. When you divide powers, you subtract exponents. An example here, if you had x to the 6th over x squared, you would get 6 minus 2 is 4, so x to the 4th. When you have a power to a power, you must multiply the exponents. So for example, if you had a squared and that whole thing to the 5th power, you would do 2 times 5 is 10, so a to the 10th. And negative exponents, the way you can make them positive is you take the reciprocal and you make the exponent the opposite. In other words, if it was negative, it's now positive. So, for example, if you have b to the negative 4th, to make that positive, you say 1 over b to the positive 4th. I use the phrase opposite because if you had a positive exponent and wanted to make it negative for some reason, you could take the reciprocal of that. In other words, flip that fraction, and that exponent would become the opposite, would become negative. Lastly, anything with an exponent of 0 is 1. So, for example, 82 to the 0th power, or to the 0 power, is 1. All right, moving on. Next, we talked about polynomials, and we had names for these, and then we added and subtracted them. So let's start with the naming. Well, anytime you're naming a polynomial, you have to worry about its degree and its number of terms. The degree is the largest exponent. The number of terms, a term is a group of numbers and variables that are separated by addition or subtraction. So let's look at an example. Well, first of all, the degrees you have to worry about. If the degree of the polynomial is 0, in other words, if it's just numbers and there are no variables, we call that a constant. If there are just variables and no exponents, in other words, hidden or invisible first powers, then that would be linear. Otherwise, if you have anything squared, it's quadratic, and if the largest degree, or largest power, or largest exponent is 3, then it's going to be a cubic. And we really don't care right now about the names of the ones larger than 3. As far as number of terms, if it's just one term, it's a monomial. 2 terms, we call that a binomial, and 3 terms is a trinomial. So, listen, this example right here, first thing I do is I look for the degree. Well, there's no exponents, so I know there's actually an invisible 1 right there, 4x to the 1st. So the degree is 1. For the number of terms, I see 4 times x, that's 1 term, and 3 is another term, so there are 2 terms. The name of this, then, is a linear, because there's 1 degree, so the degree is 1, linear binomial, because there are 2 terms. Now, when you're adding polynomials, you just need to combine like terms. I like to drop the parentheses first. So drop the parentheses when it's addition, rewrite it all out, and then I also like to mark down which terms are like terms. Remember, those are terms with the same variables and same exponents. So for example, 3x and negative 2x both have an x on them, so they are like terms. Likewise, 5 and 4 have no variables, so they are both constants. They are like terms, and we'll combine those. We want to write it in standard form, which means the biggest exponent first. So 4x cubed. And notice I'm putting a little check there to show that I took care of that. Some people like to cross it out, but I like just to notify that I've used each of them. If you cross it out and you mess up, you have to go back and erase what you've crossed out. So I like just putting a check under it. 4x cubed plus x squared plus, let's see here, 3x minus 2x is 1x, so I'm just going to write plus x. And 5 plus 4 is 9. So our final answer is 4x cubed plus x squared plus x plus 9. Notice that I've checked off all the terms, so we're good there. When you're subtracting polynomials, you need to distribute the negative 1 and combine like terms. You go negative 1, where's the negative 1? Well, it's right there. When you subtract anything with parentheses, it's kind of like multiplying everything in the parentheses by negative 1. In fact, it is like that. So I'm going to distribute this negative 1 to all three of those terms, the x squared term, the 3x, and the negative 4 term. Notice that you distribute the negative, so let's rewrite the first part without the parentheses. And we get negative 1x squared, in other words, negative x. Negative 3x, and negative 1 times negative 4 is positive 4. Now we just combine like terms like last time. So I notice 3x and negative x, 3x squared and negative x squared are like terms. I also see that negative 2x and negative 3x are like terms. And 4 are like terms. Let's add each of those up. We get 2x squared minus 5x plus 8. And notice once again, I'm checking off the ones that I have taken care of. All right, that's my final answer. The last topic we covered was multiplying polynomials. When you're multiplying polynomials, we learned that it's just distributing twice. And so that's what we're going to do. And then, of course, combining like terms in the end. So let's take this, and I'm going to walk through this example, and we're going to fill out which steps what we do here. So x plus 4, that binomial, times the binomial x minus 2. The first thing we're going to do is we're going to distribute. And we actually distribute the x plus 4 to each of the terms, to the x term and to the negative 2 term. So I want you to write down that you distribute the x plus 4 in parentheses. Think of that x plus 4 all as one unit, as one thing that we're distributing, and this becomes a little bit simpler process. So notice the x plus 4 is there, that got multiplied by x, and the x plus 4 is there, we got multiplied by the negative 2. Now that we distributed the x plus 4, we're going to distribute each of the other parts. But before I move on, I want you to notice those two things in parentheses are always the same. If they are not the same, we've done something wrong. So the two things in parentheses at this stage must be identical because we distributed the same thing to each of them. Now, let's distribute the x and the negative 2. X times x is x squared, x times 4 is 4x. Notice you're distributing the negative 2, not just 2, but the negative 2, so I like to circle that to include the negative, so I don't forget. Negative 2 times x and negative 2 times 4, and we get x squared plus 4x minus 2x minus 8. The last step is to combine like terms. Here the like terms are 4 and negative 2. 4 minus 2 is 2, so we get, x squared plus 2x minus 8. I'm going to show you guys how to do problem number 1, and I want you to try problem number 2 on your own. So let's distribute the x plus 3. We get x plus 3 times x. And here is where I like writing this down backwards because it makes it a little, actually makes it a little simpler in the long term. So you know that 2 times 3 is the same as 3 times 2. So I'm going to write x times x plus 3. I could write it as x plus 3 times x, but when you have negatives, that gets a little tricky. So let's just write it as x times x plus 3. Then I'm going to take that same x plus 3 and I'm going to multiply that by the 5. And so I'm going to write the 5 first. 5 times x plus 3 again. Now our second step will be to distribute each of those out. But notice before I move on, the x plus 3 and the x plus 3, those are the same thing in parentheses. So I did this correctly. Now we distribute the x and distribute the 5. And lastly, combine like terms. 3 plus 5 is 8, so 3x plus 5x must be 8x. We're all done. Go ahead and try the next one on your own. All right, did you get it? Let's review it. X plus 6 gets distributed. Then we distribute the x and distribute the 2. Combine like terms, and we get x squared plus 8x plus 12. All right, moving on. The next one we have is a little trickier because of the negatives, but we do the same thing. So just keep track of your negatives. X minus 3 times x. This is where I'm going to rewrite it as x times x minus 3. And the negative 5 times x minus 3. Now we distribute x times x minus 3. And I'm going to distribute the whole negative 5, so put a circle around that so we don't forget the negative. And now just combine like terms. Negative 3 and negative 8 make, or negative 3 and negative 5 make negative 8, so we get negative 8x. and we get x squared minus 8x plus 15. Notice we ended up with plus 15 because we had negative 5 times negative 3. All right, try the next one on your own. All right, you got it? Let's check it out real fast. Distribute the x minus 4. Notice x minus 4 is identical. We distribute the x, distribute the negative 8, get positive 32 at the end there, and combine like terms, and we are done. All right, for this last one, you just have to know your exponent rules. Yes, there's a squared in there, and yes, there's a 3x. Those, as long as you do the same thing as you did before and you understand what multiplying powers looks like, you'll be just fine. So let's do the same thing. I'm going to write the 3x first here. 3x times x squared plus 2. And the negative 6 times x squared plus 2. Notice once again, the x squared plus 2 is the same in both parentheses. We distribute the 3x and we get 3x cubed plus 6x and negative 6x squared minus 12. Now, there is actually no like terms to combine here because we have no terms with the same exponents. So I don't need to do anything else here except I want to write this in standard form. And what that means is I'm going to write the largest exponent first. So I'm just going to switch these two, the x and the x squared terms. Notice that when I switch them, the 6's are going to go along with them and even the sign in front of the 6. So we write 3x cubed minus 6x squared plus 6x minus 12. So notice negative 6 is on the x squared term and positive 6 is on the x term. Try the next one on your own. All right, let's just review it. Make sure you got it. I'm going to write 4x first and I'm going to write negative 8 first. Notice I have x squared minus 5 in both of those parentheses. Let's distribute that. Distribute that. Oh, here we go. And then I want to switch those middle two terms to make it write it in standard form. So you have the largest exponent and the exponents descend in order. So we have 4x cubed minus 8x squared minus 20x plus 40. Thank you very much for watching.